Hey everyone, Aurora here with Supercharged Science, homeschool science education for K through 12. We are going to be doing a whole host of science education, of educational videos that will teach your kids chemistry all week long. Now, I know we're starting a few minutes late, sorry. We were working on the microphones, but I'm so glad that you guys are going to be joining us. If you need someone to teach your kids science, then you look no further. I will actually keep your kids happy and engaged, and you can go take a break as a parent. So I will do all the teaching for you. Today we're going to be focused on chemistry. This is the second video that we've done. Yesterday we focused on acids and bases, and you can find that video in our video library. So Facebook will automatically archive all of our videos. So just go ahead and look in the video library. Just click videos in the left sidebar, and you'll be able to find that video from yesterday. So we actually are going to get started in just a minute. As people are jumping on, I wanted to show you some of the materials you'll need for the experiments later this week and just kind of highlight some things we'll be doing. So today we're going to be growing crystals. You only need something to grow the crystals with. So you need like a clean, I'm actually going to show you using a 2-liter soda bottle. It can be an empty glass container. Just make sure it's a container that isn't a good one. Like, it's only going to be used for chemistry. You're never going to drink out of it again or never going to use it again. So that's the kind of container. So like an empty mayonnaise jar that's been cleaned out or pickle jar is perfect. You can use a can, but you can't see through it. So pick something that's see-through. And you can use water bottles or whatever that with the top cut off. I'll show you how to do that too. And you'll also need water, and you'll need a way to heat the water. So it could be on your stovetop, which I'll demonstrate, and it'll also, or you could do it on your in a microwave. Doesn't matter. And you'll also need something that, the seeds basically for your crystals. And I've got a couple of options for you. If you have Epsom salts, this is a great one for you to use. It's magnesium sulfate. You can use those. You can also use laundry soap. Now, if you're going to be using laundry soap, borax works the best. It'll actually grow overnight. Your crystals will be huge by tomorrow morning. If you're using table salt or sugar will make rock crystals. Make sure that you use it. Well, I'll show you, but they won't grow overnight. But they, especially if it's sugar crystals, you'll be able to eat it. And so this is the one exception when I'll let you eat things. But please make sure that you don't have borax crystals going in the same place as sugar crystals, because we don't want little kids eating like laundry soap. Okay, so we are going to go ahead and get started in just a few minutes. If you'd like a shout out, just go ahead and type in your name and where you're from, and I'll say a couple of quick hellos to everyone. If you're outside of the United States, make sure you also include your country. And we are going to go ahead and get started. As you're typing away, let me highlight a few things for tomorrow. We're going to talk about polymers. I'll show you how to make bouncy balls, and which is cool because they don't have to be spherical. You can make them dodecahedrons. You can make them pyramid shaped. You can make them cubes. It's super fun. You only need 2 ingredients for that, so make sure you look at the materials list. If you don't have those materials, just watch anyway so you know how to do it. It's just 2 chemicals you mix together, and it's super fun. I actually learned how to do that one, I think, in college. And on Thursday, we have a big chemistry class, so make sure you sign up for that. It's at www.superchargedscience.com/chemistry. The link is right there. Make sure you sign up for that one, because when you sign up there, I will give you the materials, the shopping list. We're going to make dinosaur toothpaste. We're going to make glow-in-the-dark slime, and I'm going to do a super cooling experiment, which is just everything is super fun. And there's a vocabulary list I'm going to send you, as well as the PowerPoint slides will have fill in the blanks that you will be able to do as you go along. So sign up for this one. It's much bigger. It's about 60 to 90 minutes long. It's like a full-blown chemistry course. So if you want to take a break and have somebody else teach your kids, this would be the one right there. And on Friday, we are going to be purifying regular coffee back into clear water. So if you have swamp muck or coffee, or just like a cup of ick, we're going to learn how to transform it. I've gotten a couple of questions about the materials. Pickling lime is one of them. If you have it, great. If you don't worry about it too much. This is something you can get at the grocery store. And the other thing is activated carbon. So those of you who are next to like a pet store or have, for example, like an aquarium, it's the same stuff. You can use a charcoal briquette, but it's not going to be the same. It's not going to filter out as well. This has an extra layer of being able to pull out the dirt molecules and really grab onto them. So if you have that stuff, great. If not, just participate so you can know exactly how to do this experiment using some substitutes that I'll outline later. water. But those are the two weird ones. I actually put order links on the shopping list that was posted on Facebook, so you can get that as well. Okay, you guys ready? Oh, shouts out. Okay, so we have, let's see, we have Josh from Canada. Good morning, Josh. And we have Emma from Houston, Texas. I love Texas. The couple of times I've been there. Hello. And we have Jacob from California. Welcome. And we have Katie and Gemma from Ontario, Canada. Hello. Welcome, welcome, welcome. And we have Sophia from the Philippines. Hello. And we have Grace from Mississippi and Evelyn. Hello, everyone, and welcome. And we have a number of people. We have, I can't pronounce your name, but you're in Germany. So hello. We have people also emailing us in, so I'm monitoring that as well. You guys ready to get started? Say, oh yeah. Come on. So I'm going to ask you questions as we go through, and when I ask you things, you're going to shout back the answer just like I can hear you. If there's people around you, please don't shout. Don't get us in trouble. But you're going to tell me the answer just like I'm in front of you, just like we're having a real conversation. If that sounds good, say, oh, yeah. Okay, now, if at any time you have questions about the topic, now don't mess this up because we've already kicked several kids out because they started chats and doing off-topic stuff with other kids. People don't want other kids talking with you guys. So you're here with me right now. But if you have a question about what we're going through, type it in the comments and I will be able to answer that during class live. Okay, you ready? Here we go. So question number 1, do you know what chemistry is? Yes or no? Tell me out loud. Do you think you know what chemistry is? Tell me right now. All right, let's see. Let's see how much chemistry you already know, shall we? Okay, so a lot of people get nervous about chemistry. You know, they don't know, is that chemical bad? Is it toxic? Am I making something that'll explode? I have no idea. The idea behind chemistry is it's predictable. Every time you make 1 cup of baking soda with 1 cup of vinegar, you're gonna get this reaction. And it just doesn't like stop working one time and totally like explode all over the house in the next. It's predictable, just like you would bounce a ball if you were to drop a ball from a certain height and you release it, it's gonna always hit the ground, always hit the ground, always hit the ground. It's not just gonna go fly out the window. Excuse me. So chemistry is the same way. And so I'm going to be showing you some basic chemistry principles today. And then we are going to wrap up the class by farming your own crystals. And I'll show you how you can make those. Super easy, super fun. But first, let's go over a couple of things that you probably already know. So check this out. So matter, we talked about matter yesterday, but matter is anything that takes up space, like air, kittens, your left armpit, anything like that. Matter is made of atoms. Atoms make up the molecules. And we talked about atoms being the smallest bits of stable matter. There are things that are smaller, but they're not stable. So what does that mean? That means, you ever play with Legos? Okay, you tell me, is there 1 or 2 things you can build with Legos, just the things in the instructions that they give you? Or you can make like 10 million different things? Come on, tell me. Yeah, like 10 million, right? Now, is there 1 kind of Lego, or they all look exactly the same? You know, like grains of rice or pieces of oatmeal, they look about all the same? Or are they all different? They're all different, like billions of different combinations, right? So there are red ones and yellow ones and green ones and some that look like bricks and cubes and triangles and pyramids and trapezoids and dodecahedrons, right? So they all look different. Now, how many things can you make out of Legos again? A lot of different ones. So chemistry is all about how we can take those Lego pieces and make different things. So for example, a Lego piece might be hydrogen or it might be oxygen. Now if I put those together in the right combination, I will get dihydrogen monoxide. I'll get water, right? So the little Lego pieces are the atoms, and the things we put together with them are molecules. See, you already know this stuff. Element. How is an element different than an atom? Any ideas? I'll give you 10 seconds. Tell me right now. How is an element different than an atom different than an element? Okay, an element is only made out of 1 atom. It could be all hydrogen, all copper, all gold. That's an element. Element is matter that only has 1 thing. It's either by itself, all by itself, 1 lonely little atom sitting on a shelf, or it could be a whole bunch of them, like the iodine you see here. This is iodine, and this is also iodine. Okay, now when you put 2 or more different kinds of atoms together, like hydrogen and oxygen, you get a molecule, like we just mentioned with water, right? So if you take a deep breath in, let it out, what just happened? All right, you've got nitrogen and oxygen and a few other bits in there. Coming in, your body is using it, respiration process. Coming out is what? Carbon dioxide, right? Carbon dioxide. Whoa, where'd the carbon come from? You. So the carbon dioxide, so C is for carbon. And dioxide, di means two, so you have two oxygens and one carbon, put it together, that's a molecule. Okay, makes sense? All right, so matter can exist in different states, right? What states are they? So now we're down here. What states are they? That's right, solid, liquid, gas, right? You probably know about two more though, especially if you've been around the block with me before. That's right, there's plasma, and then there's weird one number one, and there's like a ton of these weird states, by the way. Okay, and then there's also BEC, Bose-Einstein condensate. Okay, so let me just jump over there real quick. So a gas, how is a gas different than a liquid, different than a solid? Okay, so a gas assumes the shape and the volume of the container, all right? So these are the highlights, okay? They also have lower densities. That means there's less stuff per volume of it. Okay, kind of like foam is less dense than like a bowling ball, right? It's light for its size. Gases are more easily compressed. You can squish it, right? If you have a balloon, you can usually sit on it and squish it, and you can actually shove it into a space that's smaller. Okay, and let's see what else we want to highlight. We don't have to talk about group 8 are gases. I'll tell you that in a second. Elements that are gases at room temperature and at no pressure, those are all non-metals. We'll talk about that later. Okay, can fish drown? Yes or no? Can fish drown? I don't know. They live in the water, right? Do fish need oxygen to survive? Yes, they do. And where is that oxygen? It's dissolved in teeny little bubbles that you can't see in the water. So are the fish looking for liquid oxygen, or are they looking for gaseous oxygen? They're looking for gaseous oxygen, and you can't see it. You ever taken like a cup and you fill it from the tap, but it looks like it's cloudy and you don't want to drink it? If you look real close and it's like white cloudy, if you look real close and after a while it clears up, those are tiny, tiny little bubbles. Tiny little air bubbles that are dissolved in the water, and they all kind of rise to the surface, so the bottom will clear up first and then the top. So those are tiny little gas bubbles of air that are popping, and they're coming up near the surface. Okay, so those are gases. Let's talk about liquids. Liquids have a definite volume, meaning you can't squish it into a smaller place the same way we can with a gas. Liquids will take on the shape of the container, right? You pour yourself a glass of lemonade or apple juice, what happens? It just doesn't like fill half the glass like this way, right? And shoot out the top. Well, I guess it does if you pour really fast. But in general, it'll assume the shape of the container. Okay, think of like a liquid-filled balloon. When you smoosh one end, right? You ever seen one of these? The other end pops out, right? So liquids are just about incompressible. They're like less than 5% volume incompressible, which is why we use them in hydraulic power, for hydraulic powers on machinery like this. If you've ever seen like excavators and stuff, these are liquids inside, not gases. They're not pneumatic. Typically, they'll be hydraulic for heavy-duty machinery like excavators, backhoes, and that sort of thing. The solids, what makes solids, liquids, and gases different is basically the energy inside the atoms. And in solids, those atoms and molecules that make up the solid, like an ice cube, they're stuck together in a way that they can't move easily, so they can hold their shape. That's why you're sitting in a chair. The solid molecules are holding their shape, and they're holding you up, right? Because you're not going splat on the floor. So typical characteristics are that solids tend to keep their shape unless they're broken. And solids don't flow, right? So if you have a thing of marbles, you can get the marbles to flow, but each marble doesn't like assume the shape of the container. That would be a mess. And solids also have a property known as elasticity. You ever bounced a basketball or shoot a rubber band across the room? So all solids have elasticity. Rubber has a lot of elasticity. Here, I've got a rubber band here somewhere. And basically what that means is, here I'm looking at my wedding ring right now on my hand. My diamond and this gold band doesn't have a lot of elasticity. If I try to squish it, it's gonna break. But this rubber band, right, I can certainly change the shape, can't I? So this one has a high elasticity. Now I can stretch it so much, and when I stop stretching, it goes back to its original shape. Same thing with the basketball. If you were to look real close, when you bounce a ball, the bottom gets a little flat, and then it goes back to its original shape. Now you can also pass the limit, right? So there's a place where if you stretch too far, you'll actually break it, right? So the bonds are actually breaking in the molecules. They can't hold on anymore. You're stretching the bonds between the molecules so much that they just can't hold on anymore. That's why you actually feel a little resistance right before it snaps and breaks. Okay, we talked about plasma before briefly, but here it is. Plasma actually makes up a very large percentage of matter in the universe. Now, you don't have a lot of it on planet Earth. Plasma here is usually short-lived, or it's stuck in a tube or a television or something. Plasma is basically what happens when you add enough energy to a gas that the atoms inside that gas, the little bits that make it up, they move and vibrate so much that they start smacking into each other and they rip electrons off each other. So basically, you've got these naked electrons and these positive ions. So it's a gas that's electrically charged, and it has different properties than regular gas. It does different stuff. It glows when you do certain things. It does all kinds of really cool things. So they had to say, okay, so electrically charged gas, that's another state of matter. And honestly, if you were to live, breathe chemistry and become a chemistry professor, you would be excited to learn there are 18 states of matter. So we're only going to cover 4. Let me give you a peek at number 5, and then we have to talk about how to make crystals. Bose-Einstein condensate. So how do I explain this one? Each form of matter corresponds with a level of energy. Plasma is the highest. It's so energetic that it can give off light. BEC is one of the lowest energy states of matter. And in fact, it only happens at energy levels almost as low as you can possibly get. Basically, temperature is like a measure of energy. The higher the temperature, the higher the energy something has, and vice versa. So at absolute zero, there's like no energy, no atomic movement. And by the way, outer space is just like 3 Kelvin. We don't say 3 degrees Kelvin, it's 3 Kelvin. Kelvin is like, it's like if you ask me what's the temperature, I'd say 70 degrees Fahrenheit, or I might say 20 degrees Celsius. So Kelvin is the absolute scale for Celsius, so you can't go below 0, but you just don't say degree. Okay, scientists have figured out that if you get certain atoms cold enough, like less than 1/1,000,000th of a degree above 0, super cold, you get this really bizarre thing called the Bose-Einstein condensate, named after this Indian physicist, Satyaendra Bose, and Einstein. Nobody would listen to Bose, and so he went to Einstein and said, hey, I think I got this idea about ultra-cold atoms, and Einstein's like, hey, I think you have something. So the two of them published a paper on it, but it wasn't until 75 years later when we had lasers and magnets that these two guys at the University of Colorado at Boulder actually created the first BEC ever seen on planet Earth. And so they created it in a lab. And so they use magnets and lasers to make that happen. It's also known as a superfluid. So anyway, so you can learn more about that. But we got to get back to our class. We talked about this is the one we're going to use today with our experiment. Homogeneous. What does homogeneous mean? Now, HOMO, that's going to mean the same. So this is a homogeneous mixture or homogeneous mixture. You can say it either way. So it's like, you ever been to those places like Cold Stone Creamery where they like mix in, like you pick the ice cream, right? Like vanilla, just keep it easy. And then you put all the mix-ins in. Okay, so a homogeneous mixture is vanilla, just vanilla. Doesn't matter where you take that bite, you're still going to get vanilla through and through. So we can have in chemistry a homogeneous mixture, and it's the same no matter where you are. Okay, so it's like if you imagine having, we're going to do this in just a second, like water, and you're going to add sugar to it, and we stir until all the sugar is dissolved. You can't see it anymore. That's a homogeneous solution. So the sugar is what we call the solute. Imagine you put sugar down a chute and plopping it in, right? The water is the solvent. It's the liquid that dissolves all the stuff. And if you are familiar with Cold Stone, you know that's not usually the way people order ice cream, right? They don't just go in and say, give me a vanilla and I'm done. No, they put all the 10 million different things in, right? So if you can imagine, you ever seen rainbow pepper mills? Okay, so if you put a bunch of marbles all together, you see how they're all different colors? So this is a heterogeneous mixture. It's different, right? It's not all the same. It depends. If I take a bite over here, there's no red ones. And I take a bite over here, there's no green ones, right? Okay, so I can still separate this mixture out, even if I have to use a microscope and do it one atom or one little molecule at a time, but it's still separatable, right? You can still, if I take salt and this is an experiment I really wish people would stop doing, but they'll put like salt and sugar together and give kids a microscope and say, okay, go ahead and separate the mixtures. And they'll give them tweezers and stuff, and the teacher comes back in like an hour. It's really frustrating for the kids. I think just doing it for a couple of grains is fine. So you can see, hey, they really are different. They look the same when you're zoomed out, but when you zoom in, they're different. But anyway, so that's an experiment that is done. Okay, so you got it. Those are the basic concepts that we're going to build on now. There's one more concept I want to just remind you that you already know. One of the first things that teachers will teach in a chemistry class is the difference between physical and chemical change. Okay, physical change, this is something when you change the shape of an object, like you wad up a piece of paper. If you light the piece of paper on fire, now you have a chemical change. You're rearranging the atoms that used to be in molecules and make up the paper, and now you're rearranging them to other things like carbon monoxide, carbon dioxide, ash, so forth. Make sense? How can you tell if something is a chemical change? Okay, if something changes color, gives off light, like those light sticks at Halloween, okay, or absorbs heat, maybe they'll get cold when you do it, or it makes heat, it gets warm, right? That's a chemical change. That's an example of something chemically going through a reaction. How about a physical change? Some examples of physical changes might be ripping up paper, rolling out dough, stretching rubber bands, blowing bubbles. These are physical changes. This is not a chemical change. Okay, what about eating an apple? Physical or chemical change? Which one? Quick. Careful. It starts as a physical change, right? You're actually changing the shape of the apple when you take a bite. But as you're breaking it down with your teeth, your saliva gets involved, right? That's the first step of digestion. And what happens later when it hits your stomach? That's right. The acids in your stomach are going to break down the food. Good, good. How's this feeling so far? You guys doing good? Okay. So there are all kinds of different, we could actually spend a long time. We're going to save some of this for tomorrow. We're going to talk about how, with the periodic table, and we're going to talk about matter is not just one kind of element. It could be lots of different kinds of elements. We'll make sure we'll do that tomorrow, and we'll talk about all the different kinds of elements in there, and we'll even talk about chemical reactions. But right now, I want to talk about growing some crystals. Are you guys ready? Okay, so I've gotten a number of questions that come in. If you're wondering about this picture, these are the crystals we're going to be growing up here. And if you're wondering about this picture, this is a chemical reaction that's reversible. Actually, most chemical reactions are reversible. Just like phase changes, you know how you can take a thing of water and leave it in the sun, and what happens? Yeah, the puddle will eventually evaporate, right? The heat from the sun will add energy to the liquid water, and that will loosen those bonds up. They'll turn into gas, and they will evaporate, right? The puddle disappears. If we take that puddle and now it's overnight and it's below freezing, what happens? It turns into ice, right? What happens? So the energy came out of the puddle and those liquids started to lock together into a solid, okay? So phase changes are reversible, right? I can take that ice cube, turn it into a liquid, put it back in the freezer, turn it into an ice cube, and then I can stick it in the microwave. Now we are in a gas phase, so I can go back and forth. You can do the same thing with a chemical reaction, right? Not all, but most chemical reactions are reversible. Sometimes you have to add energy to make them go, and sometimes the reaction will just happen by itself and you get energy. There's this really cool experiment we were talking about yesterday, and this is for folks that are part of my online eScience program. So this is an online curriculum program that there's an annual and monthly membership for. So one of them is the silverware car wash experiment. And so basically you're taking some silverware that nobody likes to polish, and it's got all these black spots on it. Those black spots contain sulfur. That's why they're black. And what you can do is you mix up a solution, line your pan with foil, stick it in, and you're basically making a battery. We're adding energy because we're heating it up, and we are taking the sulfur off the spoon, putting it back on the foil. So we're taking the sulfur, which is combined with the silver, taking it off, having the sulfur stick to the foil, and we put the silver back on the spoon. So you can actually basically electroplate your it's almost like electroplating your spoon, and you don't even have to polish it anymore. As if you know something about chemistry, you can simply do that. Okay, so you guys ready? Okay, so now we're going to do an experiment, and we're going to talk about supersaturated solid solutions. Blah. Say that 5 times fast, right? Okay, so this is the magic behind crystal farming. Are you ready? Okay, so what you need to do is you need a container. You can do it with me, and you're also going to need the thing you're going to make the the thing you're going to make the crystals out of. Remember, it can be borax, it can be Epsom salts, it can be regular table salt, doesn't matter. You are going to need a lot of that stuff to put in your solvent, a lot of the solute to put in your solvent. So, for example, you're going to be surprised how much this will fit into your pan. So here's the basic idea. I'm going to show you a video really quick. It's like 2 minutes long. Of me doing this at the stove, because I don't have a stove in here. And then we're going to come back and I'll walk you through the steps even further. So if you don't have any materials, here's how you can still participate. Grab a pencil and a piece of paper, and as I'm going through, I want you to draw a picture and take a few notes of what we're doing. Label it so you know exactly what to do. I'm going to give you some magic ratios, like for sugar it's 8:3, 8 cups of sugar to 3 cups of water, but that may be too big for your container. So instead of trying to get the numbers exactly right, let me show you what you're going for so it makes a lot more sense. You guys good? Okay, now by the way, if you've just joined us, I know with Facebook Lives people like jump on and off all the time. I forgot to do this earlier. My name's Aurora, Supercharged Science. We are growing crystals, and this is a free class for kids. And so if you sign up at this link here, you will get to participate in the big chemistry class on Thursday. It's not on Facebook Live, and it's got way more content than we have time for today. Okay, so make sure you write that down now, because I'm going to flip over to the video. You ready? Okay, so let me show you the couple of easy steps, and then we're going to come back and we're going to talk about it. Ready? So here is me at the stove. Where am I? I am over here somewhere. Where is my stove? My stove is here. Nope, stove is not there. Where did it go? Give me just a second, I'll find it. Hang on just a second, it looks like it got closed, hang on. Let me find it for you. Here it is. Okay, it's firing up, give it just a second. Because we're going to do something, we're going to do some cooking on the stove. You're going to need an old pot that you don't care about. This one is actually my crystal growing pot. Okay, so it's not one that you're going to be eating out of later. Okay, and this is my pretend stove here. I actually have a real working, kind of a portable stove here. If you have a gas stove, that'll work too. Okay, and you're going to put your pot onto your stove. So the ratio you want to start with is a 1-to-1 ratio of water to laundry soap. Okay, so I've got 1 cup of water here. I'm actually going to do 2 cups of water and 2 cups of my borax. Okay, and then you want to make sure you rinse this out really well, because it's got laundry soap in there, and if this is something you usually use for eating, laundry soap is probably not on your regular eating menu. Okay, so you want to wash that out real well. Use an old spoon and go ahead and start to stir it up. And for me, I'm going to be turning on my oven right here. So you want to add heat to your solution, okay, and kind of stir, and you want to watch it as you go. This process will take between 5 to 10 minutes. You don't want to boil the liquid inside, but you want to get it close to boiling. So you'll start to see some steam kind of rising up out of the top of the pan. Okay? And you just want to stir it around and stir it around. And as you stir and as it heats up, you'll notice that all the laundry soap has disappeared. So at this point, you stop measuring and you just use your box and dump in some more. You can see the actual bits of borax in there. And you stir it around and you stir it around, and as you're heating it, there'll be a point where the solution goes clear again. And so you say, okay, and you start adding more soap. Okay? You will be amazed by how much borax you can actually dissolve into 2 cups of hot water. It's incredible, which is why we started with a full box of borax. Okay? So what you want to do is continue to stir as you're heating. Stir, stir, stir. And you can actually turn the heat off at some point and let it settle. okay, especially if it's a little cloudy and there's a lot of churning going on because of the heat that you're adding, and kind of let it settle. And if you notice that you can see the bottom of the pan again, it's time to add more borax, okay? Okay. So you're going to continue to add borax until you've got the solution near boiling and you've turned off the heat at that point, and you can no longer see the bottom of the pan. Okay? At this point, you have what we call a super saturated solid solution. It means that you have mixed in the most amount of solids into your liquid. Okay? And at that point, you can do one of two things. You can use the solution as it is, just don't use the dregs in the bottom, okay? Or you can add just a little bit more water and continue to heat it up, and that little bit more water will actually start to dissolve those little bits that are in the bottom, okay? So you want it right at the point where if you were to add just a little more borax, you couldn't dissolve it in, but adding just a little bit more water would actually make those few bits on the bottom dissolve. Okay, so that's the point that you want this. The success of this experiment really depends on getting your solution to that point. Okay, so you want to make sure that you spend time doing this part right so you can get the actual crystals at the end. Okay, so it looks like my solution's just about ready. So your next step is to actually pour the liquid into your glass container. Now, you don't have to use a glass container. I actually used a soda bottle that I used some scissors and I cut off the top part of the soda bottle here. So I just had the bottom here. You can use whatever that you have around that will contain your solution for you. Okay, now you don't want to pour your solution while it's hot. You want to wait till it's at a temperature where you could actually stick your finger in and it's not going to scald you. That temperature is between 120 and 130 degrees. If you have a thermometer, stick it in there. And so that's the temperature you want, something that is not going to make you go, yikes! Okay, so wait till this cools off, and when you get to that point, you can kind of test it and say, yeah, that's good enough, because you don't want to melt any of the plastic that you're working with. Okay? So I'm going to go ahead and pour my solution in. I already have a bottle prepared. Okay, and I have a few crystals at the bottom of mine that are already starting to form, and I don't want to pour those in because that will actually start a huge chain reaction in my container here, and actually the whole thing will turn into a giant rock. And if that's what you want, then that's fine. But now your water may be a little clear, maybe a little cloudy, it may be a little yellow. Whatever it is fine. So after you already have your solution in here, you need to make something for the crystals to attach themselves to. Okay, so unless you're making a geode where you want this whole thing to be a crystal, usually you want the crystals to grow onto something. So I have a pipe cleaner here, and I'm going to cut the pipe cleaner into 3 about equal lengths. Okay, just like so. And I can wrap my pipe cleaners around each other to make an interesting shape. You can make any shape you want. Okay, and I'm gonna go for a snowflake here. Okay, just like that. And then I'm going to take the top pipe cleaner and curl it around. You can use a pencil, or I have a wood skewer here. And then you can kind of lay it on top of your container. And you'll notice that my snowflake is above the water line. So this isn't going to work. So I can add more of my solution from my pan into here and kind of fill it up. Or I actually have already punched a few holes in the side of this so I can lower it down more. Just like that. And I'm actually going to add more liquid so the water level raises up. Now these borax crystals grow really, really fast. Now this crystal here has been sitting for 12 hours, and I have a paper towel here to catch the drips when I pull it out. And so basically you can do these before you go to bed, and in the morning you should have crystals. This entire snowflake is covered with crystals. And you can use the paper towel to kind of let them dry off. Make sure that if you have small kids around, they know these crystals, which look pretty identical to salt and sugar crystals, make sure you know that these are not edible. This is laundry soap, basically. You can see the different crystal structure right in here. You can see how jagged they are and how they look like giant cubes. Okay, so that is how you grow laundry soap crystals. So what do you think? Is that cool? So you don't have to just use laundry soap, the borax that I mentioned. A few people asked if borax was dangerous, so please look through the comments. I did answer those questions. It's actually not. I also posted the MSDS on that, which is the data safety sheet that you can read over. It is banned as a food additive, and I think that's where the confusion is. You're not supposed to eat it. So, and it does cause skin irritation in a few people. Oh, now if you're looking here, you have to make sure you pull out the crystals quickly. You don't want this to sit more than a day or two, because the bottom also formed a geode. You see that? And if you don't pull out your crystals, the one that you put on the pipe cleaner is going to cement itself into the bottom and you won't be able to pull it out. Now, I like using plastic containers, especially with the borax, because in case that does happen, I can just cut this away. If this had been a glass container, I wouldn't have been able to do that. I would have had to break the container, and then now we've got glass everywhere. So, okay, does that make sense so far? Okay, so what did I do? So to recap, I got a super saturated solid solution. What does that mean? So saturated means, so people have been asking me, what's the ratio for salt, and how much salt do I need to put in? Oh, I've got sugar. I don't know how big your container is. So here's what you do. You put some warm water in there, not hot, just warm, from the tap, and you put it about 2/3 the way, maybe 2/3 to 3/4 the way, and then, or half. You can start with half because you can always add more. Suppose you've got your container, now you filled it half with warm water. Now you're going to add your solid stuff, your powder, your Epsom salts, your table salts, your sugar, whatever you've chosen. You're going to add that a cup at a time, a half cup at a time, whatever, however big your container is. And you're going to stir. And then you're stirring until the bits are gone. Then you add more. And you stir again till the bits are gone. Add more. You're doing this until the bits don't disappear. You ever made lemonade and you're like, hey, how come there's always sugar? Now I know where the sugar is. It's at the bottom. So that's what we're going for. You want to stir it so much that there are still bits at the bottom. Now we've made a saturated solution. Now, if you've used not a plastic container, but if you've used a glass container, you can just stick the whole thing in the microwave for about a minute or two. It'll heat it up and all those bits will be gone. Or you can dump it into a pot on the stove. You can start this whole thing in a pot and put it on the stove, a sauce pot, and then go ahead and stir it up. Add a little bit of heat, and you'll notice now the solution can accept even more. So now we're getting to the super saturated solution because we're adding energy. We're allowing more of the powdery stuff, more of the solids to get dissolved in there. So you've got to find where that's set. And then when that happens, you add more and you add more until when it's heated, not boiling, and we're talking like 150 degrees, 160. So when it's heated, you can't add any more. And when that happens, then you stop, don't add any more solids. Now you add a little bit more liquid and you'll see those bits disappear. Now you have a super saturated solid solution, right? So now all you got to do is you put a stick in there, or pipe cleaners, you put a skewer, it doesn't matter, put a piece of string or yarn, works really well, especially because it has those little fibers that are in there. It helps if you get it wet first and you roll it around in whatever powders you were using, and then you stick it in. Some of them may fall down, but that will seed the stick, S-E-E-D, that will seed it. And now those crystals have a place to get started growing. You can also, if you don't want to do a stick, but you want like a rock of crystals, you can put a sponge in there that's you've gotten wet and you've dipped in your salt or your powdery stuff, and then you put it in there. They'll actually grow on top of the sponge. You can just have a dish of this with a sponge on top, and the liquid will, through capillary action, come through the sponge, and you'll be able to grow crystals that way as well. So there's a lot of different solutions. Does it make sense how to do this? So you dump in as much of the powder into the water as you can, warm it up. Now you can put more in, add more until you can't dissolve anymore. And when that happens, stop, add some water, and then you're ready to go. Now, The way to get these crystals, so borax crystals will grow overnight, easy. Now, if you're using sugar, Epsom salts, you can actually use charcoal, by the way. You can make charcoal crystals. There's a lot of different kinds of crystals, a lot of different things around your house that will make crystals, but you need them to be warm. So if you have a heating pad or something, or you have a really warm area in your house, like maybe the shelf right next above the stove or something, or next to the oven, not in the oven, but somewhere where it's like the warmest part of the house. You know, maybe usually it's up on the second story, if you've got a multi-story house and it's like up near the ceiling somewhere on top of a shelf. That's where you want to store your crystals. And every couple of days, every couple of weeks, you're going to check on them, and they'll grow bigger, 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 bigger. And when you're ready, just pull them out. Periodically, you are going to want to make sure that it's not gluing itself to the bottom of the glass. Okay, how was this so far? Does that make sense? Do you guys have things you can do? Okay, a number of great questions have come in. One question was, hey, this is awesome. How do I make pink crystals? Just add some food coloring, right? So stick it in there when you're doing your stirring. You can absolutely do that. Other questions, does the water have to be hot? Yes, but not initially. So you start with warm water and then you heat it up as you go. How long will this last? I've actually grown crystals for about 9 months, and they're enormous. They were sugar crystals. It was like the biggest rock candy you've ever seen. So, so you can do it as long as you want. Can you scent it? I've never actually tried that. So if you're not going to eat them, I would say you could add a drop or two of essential oils and see, but I don't think that's going to mix with your solution. I think it's going to stay separate. But if there's water-soluble scents somehow, you could try that, absolutely. How can you make them look like Christmas ornaments? Yes, actually the one I've got here on the slide, that looks like a Christmas ornament, doesn't it? So you can get really creative with that. Okay, cool. Other questions? Can you use string? Yes. You can use string, or you can use pipe clean. You can use anything that it will stick to. You can use, I guess you could make it out of a race car, but you won't be able to use a race car anymore. You could use anything that you want. You just, the crystals need something to stick onto. These do look like sugar crystals. Thank you so much for bringing that up, Melissa. Make sure that little kids know this is not candy. So just make sure that they're not going to stick this in your mouth. Okay, we're actually going to wrap things up. I know we went a little long today, but tomorrow's class, we're going to do polymers. I'm going to show you how to make a bouncy ball. You have right now everything you need to do more science experiments. If you haven't already signed up for the big class, we're going to make dinosaur toothpaste. We're going to do glow-in-the-dark slime. We're going to make supercooling. We're going to do supercooling experiments and even more. I'll actually show you how they transform lead into gold. They've done that twice now on planet Earth. So that experiment, we're going to talk about that during our big class. And you have to sign up for that one. It's not a Facebook Live class because it's so long and it has things I need to email you and worksheets and downloads and all kinds of stuff. So go ahead and sign up. Even if the time doesn't work for you, sign up anyway. So you'll get our be on our email list. If we do a replay, we will send that to you as well in your email. Okay, I hope this has been helpful. Kids, grab your fingers right now, stick them on the typing board, and tell me what was the coolest thing from this class that you really enjoyed. What did you like most? This helps me, by the way, so I know to do more of that you like. So go ahead and type it. What did you like best? And also, if you have suggestions for me as to what else we should be doing, what would you like? You know, we're doing chemistry because so many people requested it last week during astronomy. So what should we be doing next? I don't know. I need your advice. So tell me right now, go ahead and type it in the box, type it in the comments section, and let me know what you liked best and also what you think we should do next week and the week after. That will really help me out a lot. Okay, so we are going to go ahead and close up class. I will leave the slide up for a few more minutes so you can take a look at it, but it's been my pleasure to be your coach and teacher and guide and mentor for the past 45 minutes. Parents, I hope you've enjoyed a little bit of a break. I will see you tomorrow, and I will totally do all the teaching for your kids totally free. I will do it tomorrow on Facebook Live just like we did today. Make sure you let your friends know and anybody else who's got kids who needs some help doing hands-on science and having a good time with it. Let your friends know we are happy to keep your kids engaged and excited, and just because it's important to keep their education going during this time. So we're happy to help. Just go ahead and send people to our Facebook page and just let us know. Share this video with them. Share anything else that you think they would really appreciate. And make sure you sign up for the big class on Thursday. I will see you guys next time. Take care, everybody.